talk about numbers 14 and 15 from the lab because those are kind of like the parts that were more like exercises for you guys to find out instead of me kind of showing you exactly how to do it. I wanted you guys to figure out like a way to try and make names that were better. By default, what I had you guys do was have a name generator that would just do random name, like random letters, based on characters that you roll in a random number in a range. I wanted to change it so that instead you're actually generating something that's more like a reasonable name. So let me just show you a little bit more. So for instance, if I make a function that says generate name, and all this thing does is it prints out, I don't know, we're gonna do a very simple random number generator here. This is basically, I'm simplifying the lab down. I'm not doing the entire lab. I'm just going to break down the part of the lab that is kind of like the name generation portion. And what I want to do is want to show you a different way to approach it that lets you get better names. And the general idea for generating kind of a better random name is that you have to hand tune some of the parts that go into the name. And then once you can hand tune those, you pick between the ones that you hand tune. So if you think of a name as kind of made up of 3 different parts, meaning a prefix, a body, and a suffix, and then you write kind of like your selection of prefixes, your selection of what kind of middle parts in the body, and what selection of suffixes you want. If you hand tune those, you can just pick between those and then slam them all together and you'll get a much better looking random name. And the general idea can also be used for something like weapon prefixes as well. So by initially I asked you to make a random number that just had some number of characters in it that were just all kind of random between 6 and 16. So in this case, what I'm doing is I'm not actually returning a string. I'm just going to print it out. So it's okay that you actually, in the lab, I asked for like, hey, give you back a string. In this case, I'm just going to print it out because I'm just doing this for the sake of example, just so you guys are aware of how it works. So something more like along the lines of, you had a result. And the general idea behind this originally was that you have a string that starts off empty, and then you start sticking random letters onto the end of it. What you're going to do is you're going to get a random number in range, and I believe I said 65, 91. And I'm going to talk about this more, like casting stuff later, but this is basically a way to convert a number into a character. Otherwise, you actually just get a number. I think it was 65 to 91, yeah. All right. And the reason why I did this is so that I can generate maybe 20 names like so. So I can call this function I wrote 20 times and have it generate 20 different random names. Let's see if this compiles first time. So you all should have had some random names. Looks like I'm including some left brackets here. Maybe my random number and range is a little bit too high. There we go. So you get names like this, which aren't like super wonderful. There's a few in here that might work, like Vodwasb, but a lot of them, like NNNN, there's a lot of repeated. What's that? CNN. Like there are a lot of these which are kind of like just unlegible. They're more just like you can tell they're random. So improving upon this isn't really that much more difficult. However, it requires you to think about things. Instead of using just random characters, let's pick into kind of a dictionary of pre-authored suffixes and middle parts and prefixes that let us make a name. So what we're going to do is instead of randomly attaching a character, I'm going to create a function that lets me get a random suffix, a random middle part, and a random prefix. Okay. So there's a lot of ways to do this. I'm going to show you the inefficient but simple to do method, which is I'm going to create something like this. This get random prefix here is just going to give me back a sequence of characters that is kind of random, but I'm going to create those instead. And the general idea here, for instance, I could return like low here, for instance. If I just do this right now, what I could do is my result could be equal to this to start with, right? So I just make my result this by default. So I'm calling this function get random prefix. And what does this return right now? Always returns a string LO. So when I run this function, every single one of my names is going to have LO in front of it, right? So if I also make a function that lets me return a different body, maybe TH, and then the way the strings work, I'm going to break this apart a little bit. I'm going to get the result plus a random prefix. Then I'm going to add in the random body. And then, as you can guess, I'm going to add in the random suffix. So I'm going to make 3 functions that give me back different pieces of a name. And right now, they're all returning the same one. But I'm going to call each of these functions one after another and then stick the result onto the end of my string that I'm currently writing. So here's my get random suffix here. I'm going to get rid of this because I don't need that anymore. And I call this now. And there's 3 parts to it. However, they all combine to make one name, right? So how do I get random versions of this? How do I make it random what I actually choose? Well, I can make an array of strings. This is going to be my choices. And I'm going to make, let's say, 5 choices here. And there's a lot of different ways to initialize the array, but I'm going to show you we can do it like this. Low can be 1. I don't know. I'm kind of making things up. Something like that. I have my array of random choices. This is just a way to initialize the array, one for each. And then what I can do is I can pick a random element from within this array. So I can get roll dice. I can return choices. Now, I can return choices anywhere here, but instead of picking like an index here, what I can do is I can roll a dice. And the dice I'm going to roll is going to have 5 sides on it. And I'm going to subtract 1 on the end because this gives me a number between 1 and 5. What I need is a number between 0 and 4 to index into this properly. And then I return a random index here. Okay? I use the variable that I just created here. I'm going to repeat this pattern. I'm going to copy this whole thing, and I'm just going to replace all of these with that. Now my job is just to come up with something more reasonable, like okay. And then here, pant. Who knows, right? So the key is that each one of these is broken up into several different parts. I can actually add something here that has an empty string on it too. So sometimes we'll have no prefix on it, or sorry, no suffix on it. So I can do that if I want to. I can also, don't have to have 5 choices in here. I can have more or less. But now these functions, which I've already written and are already being called, are now indexing into this array of random prefix bodies and suffixes. And those here, I'm not doing this correctly because I need to have prototypes for all this stuff. So I need to rearrange this, which is unfortunate. You can see here now that these names are a little bit more, they're not just random, but they're also a little bit more legible, right? Like, you can actually get different styles of dialect for these names, like different regions of names, by combining these in, like, making your prefixes sound a specific way, making them have more characters or less characters. You can make them sound like Asian or Russian or whatever you want, or fantasy style, so you can add them all together like that. And now you have random name generator, which is a little bit more interesting. Okay. This same idea of picking suffixes, body, and prefixes can be used to generate your weapon names as well. If you use the same concept, you can make a weapon name that has different prefixes on top of it too, which is the other part of the lab, which was creating a function generating a random weapon for us with a random prefix and suffix. What is a random weapon except for just a name that's made up of two different names together? Right. Any questions on that? So next time you do a random name generator in an MMO, you guys ever use that stuff? You could probably just write your own random name generator if you want to, and like tune the prefixes and bodies to what you like in a name. You could even do things like, I don't know, YOLO. Right? You guys ever see names like that? 420. XXX Cal XXX, right?
Is it better like having it as a function?
I think so, because you know why? If you have it as a function, you could sometimes stick more than one suffix onto the end of it, right? So like, if I roll a dice here, we're going to roll a 2-sided die greater than 1. I'm going to add 2 extra suffixes onto the end of it. So like by having it as a function, I don't need to do anything else. It'll just generate me more things, XXXXXX pant. And you could do the same thing where maybe sometimes you generate more prefixes, right? Yeah, I mean, I tend to favor making things functions more than not, just because like you tend to get a lot more use out of something like this if you make them functions, because you can get really silly things where just by reusing the function you get like kind of funny things. But that's without me changing any code. I just call it a different number of times, right? It's very powerful. And what's nice is that I can just generate as many names as I want to, right? I can generate 100 names because it's all in a function, so. Right. You can make some sweet memes this way, I think. I don't know, just like combine like different meme phrases and just like put them all in there and then just connect them together. Hit our Calmer YOLO pant. I like this one. Maybe that's gonna be my next battle tag here. Is that High Tor Calmer YOLO pant?
That sounds like a legendary boss in WoW.
Yeah, I like yellow pants so much. I want to make yellow pants. I don't even know what that would mean, but like.
Oh my gosh, that is such a fun.
Panty yellow pants. Panty yellow pants. Yeah, I think that's kind of funny. But like it makes it so that because these things are functions, you can always change what the function does without changing who's calling it, right? You can change these back to be like something more reasonable, and it's okay. All right. That's it for the lab. Let me go over the book homework now. So the book homework I asked was to read chapter 4, pages 131 to 140. This was talking about structures in C++. I'm going to go over them a little bit more, and then to do the assignments in the end of the book, which was to use those structures. I want to talk about structures from the point of view of like why they're useful more than like how they're structured. But I'm gonna show you guys what actually is needed to make a structure. It's here. Okay. So structures in C++. Kind of as I mentioned before, structures are more of a way to logically organize disparate pieces of data and functionality into a single piece so that you can pass around the single piece, you can work with the single piece, and with it comes all the information you need to work with it as well as all the functionality you would need to use it. It's a way to not only simplify something that's complex, but it also, in a lot of cases, is more efficient to use it this way. For performance reasons, you can have structures, you can pool these structures together so that everything is next to one another in memory. And just in general, structures are a great way to split up work that you're doing. If something is a very complicated problem you're working on, by using structures, by breaking them down and like separating out the pieces of the complicated problem you're working on, you can get it to a more manageable state. There's kind of a very simple, it's like scientific process more than anything, but it's a way to like approach a problem by like simplifying the problem. So you divide the problem apart into something that is more reasonable chunks. So let's take for example that you are in charge of making an MMO, like from scratch, right? Like you are one guy, you've always wanted to make an MMO, and you've always wanted to program it and do everything. You have no idea how to program or like even where to start making an MMO. What's that?
It's already doomed.
No, that shouldn't stop you from doing it, right? There's nothing stopping you from doing it. Just the size of the problem shouldn't really matter in that case, right? Assuming that you guys have the time and that you can like feed yourself and that you have lodging, that you can take care of yourself. The only thing that's stopping you is your lack of knowledge in that area. But how do you even start with something so massive, right? You don't just start sitting in front of Visual Studio and say like, hey, okay, I'm going to start writing code, right? You don't even know where to begin. The way that you approach a big problem like that, and hopefully this is pretty common sense, is that you have to break that problem down into small pieces. Like you take something like an MMO and you're like, okay, what are the big pieces of an MMO that I have to worry about? Well, let's say I'm making like let's simplify a little bit. Let's say I'm making like an older MMO, like WoW, or like a classic 3D MMO, but in like vanilla. Now let's go with like more like 3D style, because like I think there's a lot more interesting things in there. If you think about a game like that and you think about the pieces, you have like the character, which is a big piece, right? Your character is comprised of how you move around in the world. Now that means that you have to have an environment that the character can move around in. So the character movement, for instance, can even be broken down. You have the idea of a 3D character in an MMO, forgetting about all the quests and stuff, right? Like think about in C++, like you can create, let's say forget about the character as a model. What would it take to get like a simple thing that's like a cube moving around in a 3D world, okay? Forgetting about all the multiplayer parts, forgetting about all the environment parts. You're just focusing on a cube. Now you have a cube with a camera. The first thing that you could try to do is to make something that you can respond to keyboard input. right? So maybe you have your first goal being like, I'm going to get something that looks like a flat level with just a cube that's just in the level, not even moving. I'm just going to get a floor and a cube drawing on the screen, okay? That's all I want to do. Not knowing anything else, I just want to get that going. You could probably look up some things on the internet to say like, hey, here's how you actually draw a cube onto the screen, okay? Once you have something simple like a cube, then you can build upon that to do more and more. Like you can think about like, okay, now how do I have this thing respond to keyboard input, right? I can add in that. Now he can move left and right. Maybe the next thing you want to do is be able to rotate the camera, right? You want to be able to use the camera to look around the character. This is not even having any assets or anything like that. No assets. And I think a lot of it deals with trying to approach it from a very small piece. You tackle one small, tiny problem at a time. And going all the way back to structures, I feel like structures are a great way to represent something like that, where you have a really complicated problem like an MMO, you understand what you want to try to do in the end. However, along the way you have all these tiny pieces that you're trying to accomplish. And each of those tiny pieces can be represented with data structures like this, where you have structs. For instance, if I have the concept of what I just talked about in an MMO, I have a character, which is just a cube. What represents a cube in 3D space? Right? What are the things that comprise a cube in 3D space? What things do you need? If I want to draw a cube in 3D space, what pieces of information do I need? Think about this from the perspective of like, you know, a game developer. You need the area, size. Maybe we'll just say size of the cube. What about its position in the world? Right? You need that. You just need a way to represent where it is in the world. Orientation. Let's just forget about everything else. I think these are the three pieces of information to start with, right? This thing doesn't just represent a cube. This thing represents what our player is. So you have a logical kind of combination of pieces that represents what a player is in an MMO. We can do this exercise for all kinds of things. A player is a size, position, and orientation. Eventually he might be a model as well, along with a class and a name and HP and stats and all that stuff, but this is just a simple part, right? What about something like a camera? What things do you need to have a camera in your MMO? What are the things that represent a camera? What are the pieces of information that represent a camera? Think about position, yeah, same thing. Orientation. There's no such thing as a target. A target really is just orienting yourself towards something. And that's the target is represented by maybe something else. Someone else is telling you the distance. Distance. A camera doesn't know distance. A camera has a position and an orientation, right? The other things that a camera might have is FOV. So field of view, so the angle of the lens. But that's it. These pieces of information that represent the camera are distinct to the camera. Things like FOV is something that the player doesn't really have. The camera has that. So when you're representing and talking about these things, you want to think about a game being made up of a lot of these little pieces of information. So we're building our way towards making Pong, right? Let's talk about a paddle. What logically represents a paddle in Pong? What pieces of information for a game of Pong does a paddle need to represent size? Okay. What else do you need? Position. It's a common theme. Yep. Shape. The size I'm going to say here is like width and height. Orientation. So width and height, paddles don't really rotate in Pong, so maybe just width and height and position, right? Those pieces logically represent a paddle, and then we're going to do the ball. And a ball is made up, again, in the world of position, a radius. And then also the ball has the concept of velocity, how fast it's moving and what direction it's moving in. So the way I'm writing this stuff out, I'm representing each piece in my game by stating what properties describe it. So a ball and a paddle both have a set of properties. This is what structures are used for. They're meant to combine properties under a single type. So a paddle and a ball are perfect examples of where you could use something like a structure. So when I talk about a structure, I'm talking about multiple variables that define a new type of variable that you're creating. Okay. Let's go through this exercise a little bit. Let me show you what that looks like. Here's an example of a declaration of a single structure. This is the syntax that you need to do. You guys, if you did the homework, this should be exactly what you did already. It comprises of the keyword struct, which is a reserved keyword. You have to use that, along with the name of that structure you are creating. This name that follows is something that you decide what do you want to do. You get to design the name of your type. So in this case, it's called inflatable. You could call it whatever you want to, as long as it's a valid variable name. You call this structure whatever you want to. It's comprised of any number of variables. There's really no limit to how many variables you can combine under a structure. In this case, this thing has 3 member variables. Member variables are variables that live under that structure definition. This means that when you are using your structure, the structure is defined by these 3 variables. So in this case, this example is something that's called an inflatable. It's like an inflatable toy or like an inflatable pool or something like that. It's represented by a name, so the product name, the volume of the inflatable, meaning how big it is, as well as the cost, represented by the price, right? So let's do this. We're going to do this example here. So one key thing to note is that you have to have a semicolon at the end of every structure declaration, along with a set of curly braces. This defines what a structure is. These are different than functions, like how you declare them. This is a new kind of syntax. Once you have that structure, so in this case, we create a new type called inflatable. You can now create variables that use that structure inside your program. So there are 3 variables here, one called hat, one called whoopee cushion, one called mainframe, which are all variables which use that new structure template. Okay. So let's go over a little bit more of a real example of how we use structures, and then I'm going to go over the homework and then explain how those are used too. Okay. I'm going to get rid of all this. Okay. So here's my main. Let's go back to the paddle example because I like that example here. I'm going to create a variable called paddle, a structure called paddle. One thing to note on naming convention here, typically the naming convention that we use for structures is that the first letter of the structure name here is always capitalized. So I'm calling it paddle, but it's not lowercase paddle, although that's valid. You can actually do that. We tend to uppercase our paddle. We use camel case and so if we had paddle with multiple words, something like that. Notice I uppercase the first letter of every word in this. Typically, you want your structure names to be rather short but descriptive, if possible. Notice here I have a structure with no variables in it, however, it's still valid. And in Visual Studio, once you defined a structure correctly, you'll see that it actually colored it differently, right? You see that it's like this, like greenish blue.
Teal.
Yeah, like the teal. And what did we say? We said that a paddle is made up of a position and a width and height. Well, I can have a width in here as a member, and I can have a height in here as a member too. I'm going to get to position in just a second, but I'm going to explain why. Once I have this paddle structure, I can use it in my main class, in my main function, I'm going to call this one player 1. So look what I did here. I created a variable. The variable's name is player 1. The type of the variable is a paddle. Now, ignoring what this actually is, what's inside a paddle, like I'm hiding that right now, doesn't really matter too much right now. All that matters is I'm declaring a variable using a type that I created. So this gives you the power to make new variable types. This is important because if I didn't do this, let's just say I live in a world where I didn't represent the player using a paddle, right? I'm going to represent the player using just raw variables without using any structures or anything like that. Right? So 2 variables to represent player 1. What if I added this player 2? I can easily declare player 2 here. What if I want to declare player 2 by just using variables? I would do the same thing. So these are basically the same. Like functionally, having 2 variables represent players 1's width and height is the same as having this. I can do the same thing. However, this right here is not really tenable. Like it's not really, like you can't sustain this. Like as soon as I add position for player or like some like color to the player, I have to keep adding more variables every place that I use it to represent the player 1. By creating a structure, I pack that all up into effectively what you can think of like a folder, right? Everything belongs under there. And I don't have to worry about individually representing each property. I just say, hey, player 1 is a paddle. Remembering that a paddle is made up of width and height by itself. So how do I get at these 2 variables here? How do I actually set the width of player 1? I have player 1. That's my variable that I'm using. It's a paddle type. How do I get at the width here? This is from the book. You guys should all know. Does anyone know what I used to get at the width and height here?
The
Dot. The dot is a new operator that we haven't used yet. Like, well, we've used a little bit in SFML. However, the dot just represents, hey, navigate into this variable. Go into this variable, and I want to use a type that is represented by this structure. I want to access one of the members that lives inside the structure. That's all that dot means. Okay. So this is a way that you can get at the width and height. Notice when I do a dot, there's a little drop-down box that appears that shows me the variables that I have access to in that structure. So you see height and width here in the drop-down box. That's because those are the 2 member variables that I've added. If I do this, I've set the height within player. I've set the height variable that lives inside the player variable. Any questions on that so far? Doesn't make sense. What if I want to set player 2 height? I can do that. Imagine this little dot is almost like navigating into a folder. For instance, if I went into here and I made a new folder called player 1, and inside there, I'm just going to actually use a text file here. This is kind of how I imagine it. Like, I have a folder called player 1 on my C drive here. I'm going to navigate into it and access this height file that lives inside there, right? And I can have a duplicate of it that's player 2. So I have 2 folders. By navigating into them, I'm effectively using the dot operator, and within there are my 2 properties here, which are height and width, right? These 2 things contain the height and width. So player 1, for instance, here has a height of 42, and player 2 has a height of 12. They each have their own distinct copies of those 2 variables, right? So in that case, I can also set the width. And the same way I set those variables, I can also get those variables out. Like so. You can use the dot operator basically to wherever you would normally use a variable, you can replace that variable with a value that lives inside a structure. What happens if I try, let me just run this to show you guys what it looks like. Oops, I need to remove this. So you can see here it says player 1 height is 42 and player 2 height is 12. Any questions on this so far? Anyone? Okay.
I was under the impression that you had to initialize the values when you were creating the, I guess, reference structure.
The book will tell you that you need to do stuff like this, where it's like, oh, you can initialize them this way. You don't have to initialize those variables right away. However, if you don't initialize them and try to use them later, you'll get really random variables. Why can't I just print out player 1 like this? Yeah, like you're saying print out what player 1 is. C++ has no idea how to print out what player 1 is. Even though technically it knows that player 1 is made up of 2 integers, it doesn't know how to print that out for you. Like it doesn't know, do you want the first integer followed by space with a second integer? Do you want them separated by commas? Do you want them with semicolons? Like it doesn't know. It doesn't want to know. It's not up to it to decide how to print it, right? There is a way you can override, you can implement an operator to allow it to be passed into a print function like this. But I don't recommend it. Most of the time we just explicitly print out like exactly what it is. Like so. So you can't even print this out like this. You have to print them out individually. Okay. Okay. Let me talk more about another type of way you can use a structure. So we have a paddle, and I mentioned that we have in our document a paddle has a width, height, and a position here. In Pong, what is a position actually represented by? What is a position composed of in a game of Pong? What are the 2 components for a position? We have a position. A position is actually a concept in a game. It's made up of an X and a Y component. This means X on the X-axis and a Y on the Y-axis. This means a position on the screen in pixels, where it is. Which means that this is actually another type of structure. A position is just another type of structure, which has an int for X and an int for Y. A paddle is composed of a width, a height, and a position. So this means you can actually just use position here from the structure you declared up above. Okay? So I'm using a structure inside of another structure, and this is a very, very common thing that you do. You will do this all over the place. You'll be using structures within structures because position is a very common thing. Now, how do I assign the X and Y of player 1? I get position, and I can't just set it to 4. I need to go into position one more time. And see here I'm using the dot operator twice. I'm diving into the player 1, getting his position, and then diving into that and getting the X out of that. So if I were to represent this right here in my Windows folder example, I have player 1, inside there is my height, my width. I would make a new folder here that's my position. And inside my position folder, I would have an X, and a Y. So notice here, my player is represented by 2 simple variables. These are built-in variables for height and width. These are represented by integers. And another structure, which within it has two variables which represent X and Y. Okay? And because I've added it to the paddle structure, player 2 also has a position. Okay. All right. Questions on this about declaring them and using them. Let's talk a little bit more about creating them. We're going to talk more about this stuff as well once we get to classes. Classes and inheritance and virtual functions are all like next quarter, but this is kind of like a smaller example of how we can use them. Let me also show you guys how to use arrays of players. So this, so far, I've been declaring 2 players explicitly, so each player gets its own variable. There's no reason why I need to do this, though. I can actually just make an array of players with 2 players in it, or maybe my game of Pong has 4 players in it, I don't know. But now I have an array. I can use this as an array just because it's another variable type. I can declare arrays myself. This means that I have 4 players. And all I have to do to access player 1's height is I index into that array first. So here's players at 0. So I'm going to replace player 1 with players at 0. And player 2 becomes that. So you can have arrays of structures. And this is really nice because when I have an array of structures like this, and let's say I just want to print out both players' height and position, how would I do that normally? I would do this. I would do a cout. I do players at 0 dot height, players at 0 dot width. So I print out the height and the width. And I'd also print out their position here, like so. So I have 2 lines here for player 0. So if I want to print out player 1, I could do this. Or sorry, player 2. He's index 1. I could do this. If I want to print out the next player, I could just repeat this. Like so. And one more time for player 4. Right? Now keep in mind, I haven't initialized the variables for players at index 2 and 3, so this will give me really random values. You guys can see I'll print out the position, the width and height, position, width and height, position, and this is width and height and position. What if I wanted to have my MMO that had, I don't know, 10,000 players in it? How do I print out all the players' heights, positions, and widths? Yeah, I would use a for loop here. And instead of explicitly writing out each one of these, I just replace the value here with I. Okay? And I don't need the rest of these. This will print out all 10,000 players for me. All with uninitialized memory. So I'm going to get a lot of garbage values here. I don't have to have garbage values. I can actually write a loop that initializes them all for me too. What if I just did this? I wrote a loop that did this. So now they all have the same position. Now I have 10,000 players, all with a position and width and height. I don't have to have them all be the same either. And you guys get the idea that I have my array of 10,000 players, and my array here, which now has all different values in it, represents that many players, and my code is very, very small. I could change the number of players that I want to very easily. Maybe I go back to 2 players. And it still works exactly the same. The code functions the same. There's my 2 players. All right. So structures are a thing that you should be using as much as possible. And I think I think the ability to identify what fields go into structures is something that takes time and practice to like understand how to break something down to make something like this. But I think that the more you do it, the kind of easier it becomes to think about like what is comprised of in a game. Like think of a game that just what game came out recently that a lot of people are playing? For Honor. Have you guys seen the people playing For Honor?
Yeah.
It's like almost like a Dark Souls, but like medieval and like massively multiplayer. Well, it's like what is it, 4-on-4 or something like that?
You mean that's not Dark Souls?
Yeah, it's not Dark Souls. It's just the combat is like all about pairing and fighting. So you take a game like For Honor, and I think it's kind of fun to like go through an exercise of breaking apart that game as well, like to represent the things that are in the game in structures that can be represented in code, right? Imagine you're making like a 2D For Honor, right? Like a top-down 2D For Honor game, right? What are the pieces that you need to represent the things in For Honor? So if you guys aren't familiar with For Honor, it's like it's a competitive multiplayer game. There's different game modes and stuff where you represent like a class. You have a class like Samurai or like Barbarian or like Knight, and your objective is sometimes to take over a point, sometimes it's to kill the other player as a duel. But generally the combat is you have a stamina bar and you can only do so many things before you run out of stamina. And you can block or parry and you can attack, and you're basically playing this like rock, paper, scissors kind of game with the other player to try to figure out like what move you should do. So in For Honor, let's represent one of the characters in For Honor. What is a character comprised of in a game like For Honor? What are the pieces that are made up of it? Position, right? Size, okay. What about things like stats? Like health, stamina, right? What weapon you use, right? What else is there? Attacks. Someone said attacks, and I think that's really interesting because that is, I think, one of the things I want to dive into. So let's break this down a little bit more. You guys did a good job of identifying like the chunky parts of it. However, we need to dive a little bit deeper. We can't just say like weapon and then leave it at that. We have to actually describe what is a weapon in For Honor, right? So let's talk about this. A position we know is made up of, we have a position structure, it's made up of an X and a Y, right? So X and a Y. So we have a structure that has a position on it. This thing is represented, I'm going to actually go ahead and represent the position here. A position structure has an X and a Y, and these are both integers. And let me do this actually in code. I think that's actually going to be better to do in code here. So I have my position here. Let's take my character and make a struct for a For Honor character, right? And he has a position, which is, I'm going to say this is pause. He has all these other ones too. Size, health, and stamina. What is size in a For Honor character in a 2D For Honor game? What is size? It would be width and height, right? So why don't we make a struct for size, which has a width and a height. What is next on our list? Health. Health, I think, can just be an integer. Same with stamina, which is nice. Now, weapon. This is kind of interesting. What is a weapon? I think it's another type of structure. But what are the things that comprise a weapon? You have a string that's a name. You have an int that's damage. You have something that is range, right?
Weapon has health too, though.
Does it have health?
It could get damaged.
Does it get damaged? Let's just leave it simple and say it can't. Damage itself is actually interesting too. Most weapons don't do like a flat amount of damage in a game, right? Damage is usually made up of like a min and a max damage, right? Okay.
Would it depend on class? Like a bow, and there's a...
I don't think the weapon itself, like a bow that's wielded by you and me, technically does the same damage. How effective we are with that is not a property of the weapon. That's a property of the character, right? His effectiveness with the weapon is there. So we're going to say he has a current weapon. Can a character have more than one weapon in For Honor?
Yeah.
Okay. Let's just say he can have 2 weapons in there. We're going to get into something called dynamic arrays later, which let us have an unknown number of things like weapons, where you can have 1 or 100 weapons. Attacks. Here we go. What is an attack? Well, yeah, you have something like a slash, which probably has a name on it, right? You have. Does an attack have damage too? Well, how does that damage tie in with the weapon damage? Let's say an attack does 10 damage, your weapon does 10 damage. How do those two combine?
Based on the stats of the player.
So I'm going to say that, does an attack actually have damage on it? Isn't the damage determined by your weapon? But then why would one attack do more damage than another? Right? What's that?
What do you mean if they have various combos or?
Yeah, well, like, let's say I have 2 attacks, right? Each with the same weapon. I have a quick attack and a heavy attack. Same weapon. My weapon has a damage here. How do I represent attack as, like, when I hit you with a quick attack, you'll take, I don't know, 5 damage. When I hit you with a heavy attack, you'll take 30 damage. Power? I like that. Maybe it's a float that's a scalar. Maybe this thing is a weapon scalar, right? Maybe an attack doesn't have raw damage. Maybe an attack actually just takes the weapon damage and scales it up or down based on the type that it is, right? In that case, you also have what else do attacks have? If you want to use 3 quick attacks, you can do them in a second, but you can't do a heavy attack more than once a second. Like, what is that represented by? Someone said speed. We can say, like, cooldown. This is how much time has to pass before you can attack again, right? So you have a name for an attack, you have a scalar for the weapon damage, and then you have a cooldown for how long it takes before you can attack again. That is what represents an attack in our game. And how many attacks? Let's just say we have 2. Let's just say we have 3 attacks here. Okay, I think this is a good example of a For Honor character. Before I go to initializing these things, I want to talk a little bit, because this exercise that we do is basically what you do as a game developer making a feature. Your first object in your head, maybe you're not doing this in code, but you're doing this in your head, is to logically kind of organize the pieces of your game. Your job is to make structures like this, because this lets you deal with individual pieces in a much more simple way. When I'm talking about a weapon, I only have to care about these 4 pieces of weapon. For instance, what if I had to represent a character like this with only using 1 structure, right? Okay, let's say we do a bad job of doing this. Okay, how do I represent a weapon now in this? I have a weapon is made up of a name, but I can have multiple weapon names. So I got 2. A weapon is made up of I have to have 2 of those guys. I have to have 2 max damages. I have to have, what does a weapon have? Range. Now my attacks have a string for attacks, and then they have a cooldown. And they have attack scalar. Okay. So this is what it looks like. This is just based on what we have. This is what a structure looks like if we don't use any other structures inside of it. Okay? Compared to something like this, where we have very simple structures. The benefits should be obvious, right? Like having multiple structures. Let's say, for instance, I want to add another property to attack. Let's say I want to add not just a name here, but I want to add a collision size. What do we call it? We have size. I'm going to call it collision box, because attacks have how big they hit, right? Some attacks are really big, and some attacks are very small, like a thrust. This collision box, if I didn't have it, I'd have to have like attack size width here, height to represent the height and the width of the attack. But by using the structures here, I literally don't touch anything inside my character. I've just added a collision to my attack structure, and it just works. I just add it here. Okay. And now this, what if we lived in a world that didn't have any structures at all? Right? What if I lived in a world where I had to represent a For Honor character without using structures, like that? But wait, I have 6 players in the game, right? So now I need to have 6 of these for each one. Wait, so that means I need to have 6 of these? I need to have a 2-dimensional array with 6 of these guys? I meant to have, actually we have 8 characters in it, right? So I have to update that and have 8 characters in it. What if I wanted to update it so I have 2 weapons? Instead of 2 weapons, I have 3 weapons, right? This, without using structures, you're dealing with basically kind of an overwhelming number of pieces of data. I don't want to ever deal with this kind of crap. All I want to do is I want to make a For Honor character that says player 1, and there's my character, right? That represents everything that I need because we just went through the exercise of it. And if I want to have multiple players, I want to have 10 players. That's all I have to do. I just made 10 players, and they're all represented individually, right? That's why structures are really important. That's why arrays using structures are also really important too. So today's lab, I'm going to give you guys this. This is basically the exercise of representing pieces of data inside structures. But I want you to think about a game by its pieces, right? By its chunky, like what represents a character in the game. And even when we took a simple example like a For Honor character, you can see there's a lot of pieces that comprise that character. Okay. Any questions on this? Yeah.
Do structures have to be placed outside the main?
Structures, so they don't have to be placed outside of main. However, if you ever want to use that structure inside of a function, they have to be accessible outside of main. I can move these, like watch. I can actually put it right inside here. I can actually put a structure inside here, and it works. But let's say I want to make a function that's like create character, like what we did before, right? I want to create a character. And this is actually going to return, I'm going to write a function that returns me one of these guys. That returns me this structure. I can't because the structure, the lifetime of the structure is within the curly braces as declared, just like any other variable. So if you want this thing declared and accessible in functions, put it outside here. Yeah, outside of main. And here's my function. Remember, a function is just a type here, followed by the name. So there's my function name. Here's my type. I can have a string here. I can have void. I can have int. Or I can have the variable type that I just created. I can just have it return me one of these guys here. What does this actually do? Well, I'm going to make a new variable. I'm going to get the position dot x equal to 10, maybe rand 50 plus 20. I can make a character, and I can just return this character at the end. So if I ever want to make a character and make a function like this and use it, like that, I created a function called createCharacter that returns me one of the structures that I created. You have to have the structure outside of main. I can even have just be one variable here to simplify it, like so. All right. So I want to go over any other questions about how structures are used. Yeah.
So if you did like a random height and a random position,
Yeah.
how would you make it so that it just holds one,
Mm-hmm.
and then you're able to call upon that one instead of it just
Random every time, you mean? So you don't have to have it be random. You can have it be like static every time.
But if you wanted it to just be random though,
Oh, I see.
could you do that?
Yes. So you're talking about like maybe like a spawn point? Like
Yeah.
maybe you have a character at a spawn point. You could have something that's like, get me a position, get spawn point. Why don't you write a function that gets you a spawn point? And in this thing, you have a position. You could just return. I'm going to start simple. I'm always going to return, let's say I have a spawn point at 150. At 150 and 50. So here I'm making a position. Remember, position is x and y. I could just say new character be equal to get spawn point, like that. And that will always return me 150 and 50. But remember what we did with the names, where you can make an array. Let's say I have 4 spawn points. So what I can do is I can initialize each spawn point like so. I can have 4 of these, each one being slightly different. Something like that. And then I just return spawn points at rand modulo 4 plus 1. 3. Actually, don't need that. What I've done here is I've made 4 spawn points, right? And I've said it's one of these things, and I just return one of them randomly. And if I want to adjust the spawn points, I just change the numbers here. And every character that's created calls this function, right? This function will do what our name generator used to do. There is another way to do this too. Like, you don't have to do each one like separately like this. You can actually just do kind of like what we used to do before, which is like separate these out. This makes it a little bit easier. You can declare them inline. You can declare them on the same line instead of doing separate lines for each one. It's kind of your choice as to which one you want to do. This makes it so here are all my spawn points here. But yeah, this is a way that you can basically create it once. You still want it to be random, but you want it to be the same positions every time. So you predefine them and say, okay, I want a choice between these, and that's what you use arrays for. This is how you do spawn points in so this is kind of a simplified version, but like in Overwatch, for instance, we've placed like spawn points in each spawn room, and we'll just randomly pick one of those spawn points, right, when you spawn. And so we haven't defined them in code like this. What we do is we load the positions of those spawn points from a level. So like, imagine you're loading a file and you're looking for those spawn points. It ultimately ends up looking similar to this. Like, you have spawn points, and then we pick one at random. And that's why we choose where to put you. Okay. And so now if I see out player position here, player.position.x, player.position.y, and here I'm going to make 100 characters and print out their positions. And each one is a random spawn point. However, even though they're random, they're predefined, right? So see how the spawn points are all, like, you're either at 150-50 or 75-20. They're random, but they're within a same set, right? Any other questions? That was a good question. So I want to go over, do you guys need me to go over questions 5? Who wants me to go over questions 5 and 6 from the book for homework? Okay. All right. I think this is a good place for a break.